example 3. And I had you guys at least looking at the factoring to get you started, just trying to challenge you to factor on your own without proactive AC. Some of you are seeing it, some of you are not seeing it. So, okay. But use the function below to find any vertical asymptotes that exist. Justify your answer using the limits. So, vertical asymptotes. How are we going to find where vertical asymptotes are? Any place your denominator equals 0. When we have a quadratic like this, before we said equal to 0, we should probably factor. So if I'm going to factor the denominator first, because that's the easy one, right? X squared is x and x. My numbers need to multiply to equal negative 10 and add to be 3, which makes it some combo of plus 5 minus 2. We're there, yes?
Yes.
Okay, now my top one. Here's the deal. Doug, there's no 10 in this problem. Don't think 10 at all. 10 does not exist in this problem. Okay? What multiplies to be 2x squared?
2x and x.
So those are going to be my front terms, yes? Okay, now, what multiplies to be negative 5? It's going to be some combination of 1 and 5. There's a negative in there somewhere, yes? Now, it could be 5 and 1. It could be 1 and 5. Plus, minus, minus, plus. I'll get to that in a moment. What's our clue?
The x plus 5.
There's an x plus 5 in the denominator. So if I had to take a logical guess, where am I guessing the 5 is going to end up?
Negative 1 plus 5.
It's going to end up with the x being an x plus 5 and this being a minus 1. Do we assume it works? I would not assume, because as soon as I teach you this and get you guys all proficient, we're going to find something where the factoring has, it doesn't matter. So double check. 2x squared plus 10x minus 1x minus 5. Does it foil back together good?
Yes.
Okay. That's my quick technique. I don't know. Maybe it's just because it's in my brain, it's quick for me. It's not necessarily for you guys, but proactive AC got you there as well, yes? Okay, so what did we just discover? X plus 5, the numerator and denominator. What did our question ask us? Use the function below to find any vertical asymptotes. Justify your answer using limits. Excuse me. So what are we thinking? There is a vertical asymptote at x equals 2. So at x equals 2, a vertical asymptote, hard word to spell there, exists. And why does it exist? Because why? How do limits justify that this exists? What should my limits be doing? Go to infinity, right? Now, honestly, whether they're both going to positive or negative infinity, it's not going to matter. Okay? Whether they're going the same place or opposite place. So what we want to check is the limit as x approaching 2 from the left of h of x. I'm going to leave that blank. We'll answer it here in a moment. And the limit as x approaches 2 from the right of h of x. Now, if we're kind of, side note plugging it in, where's going to be the best, well, not plugging it in, but whatever we're going to plug into. What equation do I want to plug into?
2x minus 1.
Yeah, we're going to use the idea of h of x being the 2x minus 1 over x plus 2. So I'm just going to kind of make a little chart here. X, h of x. What are values we should plug in for x?
2.001.
2 is not going to get me anywhere because that's still going to give me a denominator
Of 0.
of 0. That is, if I write this right. There we go.
Oh.
It's supposed to be x minus 2 in the denominator, yes.
Mhm.
You guys are supposed to catch my mistakes there. You're not supposed to let the teacher make
I was
those
just going
mistakes.
for it. Whatever you wrote.
You can't do that. Don't follow me, okay? I'm not going to always lead you the right direction. Okay. Now, so x values. We don't want to use 2. That gives you a denominator of 0. We got to think left and right. So as we think left, something like 1.999, whatever, however many nines. As we think right,
0.001.
some kind of 2 points, some zeros, and a 1. Now, I don't have to know numbers here, right? I don't have to pick up my calculator. We have to use the logical part of our brain. Okay? We're going to hope it works, right? So just look at this. If I plug in 1.99, well, on top, 2 times a number that's almost 2, and then subtract 1. What kind of number are you going to get there?
Positive.
You're going to get a positive number, yes?
Yes.
On bottom, when I do 1.999 minus 2, what am I going to get there?
Negative.
We're going to get a negative. And this is going to be a bigger number divided by, specifically this would be what? Negative 0.001. You're getting, when you're doing a bigger number divided by a number that's getting smaller and smaller and smaller and smaller and approaching 0, this is going to end up becoming negative infinity. This is negative infinity because it was a positive divided by a negative. So basically, if it's something where I plug 2 in the denominator, I get 0, and I don't get 0 on top, you've just got to decide is it a positive or negative infinity. What happens when I put 2.001 in?
Positive.
Positive on top. On bottom? Positive. It's going to be a very small positive, though, right? And as that positive is smaller and getting closer and closer to 0, this is approaching positive infinity. Are we getting better at that? Okay. I'm trying to convince you don't have to pick up the calculator. Notice, I didn't have to write out exact answers, do I? Okay, I'm not asking you to do all that multiplying and adding and subtracting without a calculator. I'm just think logically here. So, right here, 2 from the left was negative infinity. 2 from the right was positive infinity. Okay, so that's our proof. There's our justification. Because our limits approach positive and or negative infinity, we know that there is a vertical asymptote. Doug?
So if we ever have a situation where the limit from the left and limit from the right both equal like positive infinity, or they both equal negative infinity, could you just write that as x, as long as x approaches 2 equals infinity, and that would be the justification for that method.
I think so. I'm trying to process like the what ifs and, I think you would be okay to do that.
Okay.
Because basically anytime a limit is equaling infinity, that's indicating there's an asymptote there. So, yeah, I think you'd be okay there.
Okay.
Now, the difference is now if it's as x is approaching positive or negative infinity, and that equals infinity, that does not mean an asymptote. But as long as we're in a situation where x is approaching some value c.
Okay.
Does that make sense? It has to be approaching some value, specific value. Because if we're just looking at as the graph goes off to positive infinity, that could just be a line. As you go right on line, it goes up, So, but yeah, as long as it's as x approaches some c value, I think that could work. Okay. Moving on. Okay, so now we get to explore limits at infinity. What we just did was more, and we did a little bit of both yesterday, but we focused more on the limits equaling infinity. Now it's going to be more about limits that approach infinity. We talked about end behavior, both in Algebra 2 and Pre-Calc, really. Okay, end behavior being what a graph does as it goes infinitely left, and infinitely right. In behavior is also commonly associated with horizontal asymptotes, right? If there's a horizontal asymptote, your graph is going to follow that horizontal asymptote or slant asymptote. That also counts as in behavior. Okay, so find each limit and explain your thinking. And notice it says use this prior knowledge to find each limit at infinity. Again, the idea is to not graph this. The idea is to use our brains. Okay? So, A, we want to know what does this graph do as it approaches infinity? And it's x squared minus 4 times x squared plus 3. Any thoughts at all about this graph?
Exponential. Or y equals.
Not exponential because there's no x in the exponent. When you say exponential, I'm thinking x in the exponent. And look at your face, that's not what you meant though.
Because there's a 2, so it's a. And the exponent.
There's a 2 in the exponent.
But the x is
It's like that.
I've been using the wrong.
Were you talking like a quadratic? Like y equals x squared is what you're thinking?
Yeah.
Okay, now, I agree there's a y equals x squared, but
There's an x to the 4.
there's 2 of them.
Yeah.
Okay, so we don't have to FOIL this out, but you have to look and analyze that if we FOIL this out, what do you know?
It's x to the fourth. But I don't
X to the 4th is the highest term, yes?
What does that look like?
Okay, so we're going to talk about that. So right now, what my brain's thinking is, okay, I know it's x to the 4th, and I know there's going to be some other terms, yes? Highest power x to the 4th has some things we know about it. The other terms aren't going to matter for in behavior. Okay, so you have to know that highest power. And this is working like A and B here. These are just polynomials. Okay, if they're just polynomials, we can just think about, okay, what's the shape of that graph? Now, x to the 4th is an even exponent. Okay, even when the highest power is an even exponent, we had some knowledge.
Not anymore, but I know that there's a.
We had some knowledge, had being the key word.
Yep.
I teach this as far back as Algebra 2, so,
That is the keyword.
okay,
Even is up and up, right?
even is up and up.
Oh, so.
Or, wait, I gotta qualify that. Even is up and up or
Down and down.
down and down. How do we know if this is up and up or down and down?
Positive.
It's positive.
It's a positive x to the 4th. So what I know right now is that I'm thinking this is some kind of up and up behavior. Are you with me?
Yeah.
Okay. Now, if it was, well, we'll get to it on the next one. Okay, so that rings a bell now that Doug says that.
Yes.
Okay. Okay, good. Now, officially, an x to the 4th is called a quartic. FYI. Okay, just throwing the vocabulary out there. Okay, so this is a,
How did they get quadratic first square?
now, a quartic,
There's 2.
trying to think, I just spelled that wrong, first of all, I just realized.
Quadratic is
Okay, so quartic, we looked at quartics in pre-calc. I can visualize where they're in the notes. But, whoops. It could be a W type shape.
Oh my gosh, I was right. Sorry.
Now, and when we think about that W, it could be a lopsided W, yes? There's a lot of different things this could be. It could be lopsided the other way. It can also just be a wider parabola. Is this in the pre-calc notes or was this in
Yeah. I
the old
think so.
calc notes?
Yeah, pre-calc.
It's pretty.
Okay, you remember seeing graphs like this?
Yes.
Okay,
I can actually visualize it in the notes as well.
okay,
Bit of X.
okay. That's why I was just like, I'm pretty sure.
Yeah, because
Okay.
of the different, like, yeah, what kinds of.
Okay.
X's.
So, This is a positive x to the fourth. We decided what we used in algebra 2 was up and up. We didn't use that in pre-calc, but that I unofficially use that in pre-calc. I guess let me say that. Okay. Now, our job, find each limit at infinity. So we want to know this limit as x approaches infinity is going to be what?
Infinity.
As any of these graphs go to the right, that's x approaches infinity, where is the graph going? Up to the positive infinity. Okay? So, I don't know, I should have set this up differently. The limit as x approaches infinity of x squared minus 4 times x squared plus 3 is positive infinity. And you could do that pretty quickly, couldn't you? We've spent probably 5 minutes on it, but
It was pulling back knowledge.
It was selfish.
Past.
it was getting now. Here's the next thing. Can we do this next one in a lot less than 5 minutes?
Yeah.
Yes.
Let's
Yes.
time right now.
Okay, that's and I'm just throwing out random. I don't know how long it took us, but you get the idea. The limit as x approaches negative infinity of 5x cubed minus 2x plus 4.
It's either down and up or up and up.
Right?
But
Down
since
and
it's
up.
positive, it's gonna be
Positive. Down and up. Positive.
Okay. So it's an odd exponent. So now we're obviously thinking either down and up or up and down. Because it is positive, it is down and up. Okay. Again, we're pulling back the knowledge, right? So this is a cubic function. What do cubic functions look like?
they look like the tangent function.
It's the squiggle.
Okay. It's the squiggle. Whoops.
Yeah.
Flatten in the middle.
Okay. Kind of looks like that. A cubic polynomial can also do like this. Okay. Can also do something like that. Either way, my end behavior is down and up. This question was the limit as x approaches negative infinity of this piece.
It's negative.
Are you guys with Hannah? Negative infinity? Because as my graph goes left, it's moving downwards. That is what you said, right?
Yeah.
Okay. You just have a weird look on your face, like I totally...
Because I'm thinking from left to right. So it would be
But this is as x approaches negative infinity, so as we go left. Okay. 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 I didn't get official with all that, but we got the gist of what we're doing. Okay, C.
What is it when the powers are equal?
Ah.
Oh, there's none. There's no.
No, there is one.
You use coefficients.
One.
So it's 3 over 1.
Okay, so this is, okay, we're there, we're getting there. So when you have a rational expression, you have to look at the biggest powers. My biggest powers are the same. When biggest powers are the same, or when we start thinking about the degree here, it's 3x squared over x squared. I don't care about the rest of this jazz. I care about that 3x squared over x squared. And then you compare coefficients. And so when we compare coefficients, this would create the, if you want, there's a horizontal asymptote, right?
Ha.
There's a ha at y equals 3. Okay. Now, with that in mind, what's that mean? If there's a horizontal asymptote at y equals 3, as my graph moves to the right, what's it approaching? 3. Because it's we don't know if it's coming from above and running along the 3 or coming from below and running along the 3. We just know it's running along the 3. So my limit as x approaches infinity of 3x squared minus 4 over x squared plus 1 is 3. We did that in what, pre-calc?
I like this lesson. It's easy.
You know, I just realized I actually had space. I could have just written equals 3 right there. Oh well. Okay, D.
They're the biggest powers on the bottom.
So when we look at the powers, 5x over x squared, what do you know when largest power is in the denominator?
Is it 1?
What?
1?
Nope.
There
0.
is
I feel
none.
like it's
There is a horizontal asymptote at
0.
Oh, is it 0?
y equals 0. Anytime the bigger power is in the denominator, there's a horizontal asymptote at 0. So, what is this limit equal to? 0.
So is it when the largest power is in the numerator that it's 1?
Nope.
What is that?
1 would be when the powers match and the coefficients are 1.
Oh, okay.
When the biggest power is on top, there is no horizontal asymptote. However, there's usually a slant asymptote. And we haven't done that as much, but usually there's a slant asymptote.
3 more pages.
Then there's like 3 different things for horizontal asymptotes.
Yeah, there's 3. Because you can have equal powers, bigger power on bottom, bigger power on top.
It's
Almost
mostly
done.
talking. We'll be fine.
This page, yeah, hopefully. Okay. Example 5. There are only 4 possible outcomes when you explore behavior to the extreme right or left. So, we have a situation here where the curve can increase without bound. The limit as x approaches infinity of f of x in this case would be infinity because it is increasing without bound. It is going up. So that is that right there, right? Okay, B. The curve can also decrease without bound. And that's just, it's going infinitely down. Limit as x approaches negative infinity here is, because this is looking at this one, right? The curve can become asymptotic. I don't know which is the correct, I never know. Okay, but can become like an asymptote to the x-axis. Limit as x approaches infinity here. It is running along that asymptote, which is at the 0, at the axis. The curve can become asymptotic to a specific y value. In this case, where is there a horizontal asymptote? At 3. So as x approaches negative infinity, it's going to run along underneath the 3. Are we okay with how to read those graphs?
Yes.
I actually like this.
We wish it was all like this, right? I gotcha.
Shush.
Mario.
You're not.
Anybody?
We're going to kick you out of class.
Okay. So at the bottom, calculus knowledge for asymptotes. Revisiting these rules for finding potential horizontal asymptotes for rational functions from pre-calc. You can use the idea of a limit and calculus to see why those rules hold true. So 1, we just did this. If the degree of the numerator is less than the degree of the denominator, they're calling it bottom heavy. Okay? So we had an example like that, right? Then there is a horizontal asymptote at 0, and so the limit is going to approach 0. If the degree of the numerator equals the degree of the denominator, so the powers are equal, then the limit is the ratio of the coefficients of the highest degree. Been there, done that today, yes? So you're looking at the coefficients. And the third option, if the degree of a numerator is greater than the degree of the denominator, so top heavy, then the limit, well, okay, it says the limit does not exist, and that's because they're going to argue infinity is not a real number and limits have to be towards a real number. But if we talk end behavior here, which is really what I need you guys to understand is the end behavior. That graph, when you have, we say no horizontal asymptote, right? If there's no horizontal asymptote, that means your graph is either going up or down somewhere. And if it's going up or down, it's going to approach either positive or negative infinity. Okay? Now, that's often going to be a slant asymptote. But slant asymptotes will go up to either positive or negative infinity. Okay?
Why is there an asterisk on the top of it?
It's totally fine. Let's just
Because
get
then
Got nothing.
I went around and I was looking, I was like, is there like a little
Yeah.
key?
No, I don't know.
Well,
There's supposed to be some.
oh, wait, never
If
mind.
I went back and listened to her notes, because she has recorded versions of the notes, if I went back and listened to that, she might mention it.
Mhm.
So, which on occasion, if we run into a situation where I have to be absent unexpectedly and I want us to try and keep moving on, I might pop one of her videos in and have you guys use it. I think I did that a couple times last year. What I will say about it is she'll move faster than me.
You're
Okay?
already going fast.
No thanks.
She will move faster than me. And I say that because there are times where I would have to, because last year I spent a lot of time watching the videos so that I would be familiar with, okay, what did she mean by this in the notes? And, like I kind of I know what I'm doing, but yet sometimes when you're using someone else's notes, you have to figure out what was the intention here. And so, thus the asterisk. What was the intention? I may have known last year. I don't remember this year. So, but yeah, so if I ever pop in one of her notes, it will be, you may have to do some pausing and rewinding to catch stuff. But, okay. Example 6. We are dividing, divide every term in the rational expression by the highest power of x that appears in the denominator. Then apply the properties of limits to evaluate each piece to find the limit at infinity, or thus the end behavior. Okay, I know that's fancy talk, right? Again, the idea is if you don't have the graph to look at, okay? How do we, how do we officially do this? Now, in all honesty, you're going straight to the shortcut, right? We're just going to kind of talk about the why behind it, is what this is going to do, okay? But you're going straight to the shortcut. The powers are the same. So horizontal asymptote is going to be at 2. So as x approaches positive infinity, this is going to equal 2. Now, how to make this work so algebraically we can show it. Dividing each term by the highest power in the denominator is what we're going to look at here. I'm going to write a note here. Divide each term by the highest power, but it has to specifically be the highest power in the denominator for this to work. Okay? That's what we're going to do here. Now, I'm going to write out a bunch of stuff. Okay? And you're just going to kind of deal right now. Because you're going to complain, I know, but you're going to survive. The limit as x approaches infinity. What is the largest power in the denominator?
X squared.
X squared. Yes?
Yeah.
So that means 2 terms on top, 3 terms on bottom. We're going to divide them all by x squared. And I'm going to write it out the long way. So we're going to do 2x squared divided by x squared minus 10x divided by x squared over x squared divided by x squared minus 8x divided by x squared plus 15 divided by x squared. Okay? Now we're going to clean that up. So the limit as x approaches infinity. What do you know about 2x squared over x squared? It's 2. Minus, what do you know about 10x over x squared?
10 over x.
Can one of the x's cancel at least? So 10 over x. Denominator, x squared minus x squared, 1, minus 8x over x squared, plus, okay,
Why? I don't understand why we're doing this.
Just
No, like I'm lost. Sorry.
We're explaining why
okay.
mathematically.
So officially, you guys just jump and automatically look at the horizontal axis. And I'll be honest, I'm sitting here trying to think, is there a time that you would have to work this out and show this? And that's what I'm trying to figure out. Or can you just use our shortcut? And that's where I'm not 100% like, that's where I'm trying to put it all together in my head right now, and I don't have a definite answer here.
If you look at the price, 2 over 1.
Okay, right, exactly. We're getting there. Because here's the deal. We're getting ready to take the limit, is what we're getting ready to do. So when you take the limit, you plug in the value, yes? Okay, go with me. Love the look on Hannah's face. She's like, what? So what am I going to plug in? Infinity, yes? Okay, just go with me. So this is going to be 2 minus 10 divided by infinity, if you will. Just go with it. 1 minus 8 divided by infinity plus 15 divided by infinity squared.
That's definitely wrong.
How would you square infinity?
Okay, just okay. This goes along with the whole idea. You guys know we're doing stuff from the right and the left.
Yeah.
I don't make you come up with those exact numbers, do I?
No.
We go for what's the overall idea of what's going to happen, and that's where we're going with this. Okay. So now 2 is going to be 2. If you take a set value like 10 and you divide it by an ever increasing bigger number. So, okay, let's 10 divided by 100. Okay, there we're at 110. 10 divided by 1,000. Now I'm at 1/100. 10 divided by like a billion.
1 million.
1 over a 0 minus, less than,
Yeah.
Are you seeing where it's going? What's this fraction doing?
Small.
It's smaller and smaller and smaller. What's it eventually going to be? What's it approaching?
Negative.
No.
What?
It's getting smaller and smaller and smaller. 0. Yes?
Yeah.
In other words, when you divide something by the idea, infinity is not a number, but you divide something by the idea of infinity, you're dividing by a number that's big, 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 big. So denominator is 1. Okay, now I have 8. But I'm dividing by a huge number, and it's getting bigger and bigger and bigger. What's this approaching? 0. Because remember, we were doing a limit here, weren't we? This was a limit. Now, okay, so infinity squared, that's still just what? Infinity. And I'm going to do 15 divided by that ginormous number.
0.
0. Are you following here the train of thought here?
Yeah.
Okay, we have people who think this way in calculus. Now, what's my answer?
2.
2 over 1.
Which is
2.
2. Okay. So all of that to say that this limit, and I'm just going to say the limit as x approaches infinity, and I'm just going to use f of x, we don't have a definition here, is 2. Okay? Does the graph agree?
Yeah.
All of that for that.
All of that for that. All of that for an answer we already knew. I'm killing you, I know. Okay? But it's the way I'm thinking that I need to get you guys to follow. Because when I said plug in infinity and we started talking about dividing by infinity, I caught you guys, right? I had to make you think for a moment. And I need you guys to think that when you're dividing by infinity, that's approaching 0. Just like when we're dividing by 0, we almost think that we're approaching infinity, right?
Mm-hmm.
So, okay. Looks wrong, huh? Okay, let's try the next one.
So that's when you have 8 over 8 laying down.
I know, I felt weird writing that one. I was like, this just looks weird. But now, and I'll be honest, a lot of times, I don't necessarily write this out. Whoops, I just put an extra mark in there. I just go straight to this usually. But I needed you guys to think for a moment, okay?
Do that for everyone.
Can we skip it on the next?
Okay, so this one. What do we know this time?
Power's bigger.
Power's bigger on the bottom. What am I going to divide by?
No.
X squared.
Oh.
Largest power in the denominator, which is x squared, yes? Are you with me?
Yeah.
So I'm going to write it out with my x squareds. The limit as x approaches infinity of x divided by x squared plus 3 divided by x squared over x squared divided by x squared plus 4x divided by x squared plus 5 divided by x squared. Oh, I went ahead. I just looked at my notes and I had gone ahead and cleaned it up in that step on that one, but what is x divided by x squared?
0.
No, I'm not taking the limit yet.
Infinity over infinity.
I'm not taking the limit yet. What is it just as a simplified fraction? 1 over x. 3 over x squared is x squared over x squared. There's an actual number. I needed that. 4x over x squared plus. Okay. Now, we take this limit. Okay. 1 divided by an increasingly larger number. 3 divided by an increasingly larger number. 1. 4 divided by an increasingly larger number.
0.
And
0.
what's my answer?
0.
Okay. Now, does it make sense here?
Yes.
As x approaches infinity, what are we running along? The 0, the asymptote, yes? Now, this is a good reminder, guys. There's a horizontal asymptote here. Notice, to the right it's going off along 0. To the left it's going off along 0. If we talked about, you can cross a horizontal asymptote in the middle. Horizontal asymptotes are just for end behavior. I don't think I've ever seen a spot where we cross vertical asymptotes. But horizontal asymptotes are just for end behavior. This doesn't have anything to do with the end. So you will sometimes see horizontal asymptotes cross the x-axis or cross that axis in the middle.
Will it ever run along? Like run like on it? Or will it just cross at a single point?
No, it would just cross at a single point, I think.
Okay.
It took me a moment to understand what you were asking. I was like, I don't understand. I'm there. Okay, C. Notice there's a slant asymptote, yes?
I do have a quick question. How does I'm so sorry.
No.
How do slant asymptotes just
Slant?
yeah.
We're about to find out.
Really?
Yes.
Yeah. Kind of.
Okay, cool.
Okay.
Just wait.
Sorry.
Now,
Sis.
okay. What do I want to do here? So, if we go with what we've been doing, we're going to what?
Divide by x.
Okay, so let's divide by x, right?
Wait, divide by x or oh, x.
Why are we just dividing by x?
Because x is
Okay, so the limit as x approaches infinity, x squared divided by x is x. Can I write this out without putting all the over
Yes.
x's?
Yeah. Oh my God.
Minus, I'm writing it out that way, you're going to have to write it twice. 4x divided by x is going to be 4 minus 3 over x.
1.
X divided by x is 1 minus
2. Good job.
now. Okay. If we, and I say plug in infinity, you can't really plug in infinity, but as we think about this limit with the concept as x approaching infinity, what happens here?
You have infinity over 1.
You have infinity minus 4, technically.
Minus 0.
Okay, infinity minus 4, 3 divided by infinity is 0, over 1 minus 0. Well, generally speaking, what's that going to be?
Infinity.
No,
Negative 4.
If I take infinity, a really huge number, that, well, and really, infinity is not even a number, right? It's the idea of approaching infinity. and I subtract 4, we're still
Approaching.
approaching infinity. And we divide by 1, that doesn't change anything, does it? Okay. So this is going to end up being infinity. Now, okay. So, sorry. I was trying to process how I want to, because I also want to answer Sophie's question. So if we look at the limit of this as x approaches infinity, it is going to equal the infinity here.
But I'm sorry.
Are you wanting to, let me delve into this slant asymptote real quick
Okay.
and see if that answers a question. So in order to deal with the slant asymptote idea, which we're finished with this problem officially, okay? But this is a good time, and I even have it in my notes to talk about slant asymptotes. Slant asymptotes are a result of what is my numerator divided by my denominator. Now, here comes a review of, what kind of division is this called?
Synthetic.
Power?
Synthetic.
Okay.
Oh.
Oh my
I cannot come up with the word. Okay, well, okay. You have a choice here, guys. You have a choice. We can either do long division with polynomials,
Or you can make different now.
or we can do synthetic division.
Are you okay?
All right. Synthetic division it is.
Synthetic division, please.
You can make it perfect.
So, my numerator, what are we dividing into? X squared minus 4x minus 3, which is what coefficients?
1, 4, and 3.
Negative
Negative 3.
four.
Oh,
Let's get some negatives in there, please.
Yep.
And we'd have to have some zeros if any place values were skipped, right?
Mhm.
Just throwing that out there while we're talking about it.
Yeah.
What goes in my box?
See that I couldn't tell you.
Negative.
Okay, if we're dividing, now first of all, synthetic division only works when you're dividing by a linear factor. That linear factor is x minus 2, so we actually put in a
2.
positive 2 there.
Okay.
Okay, it's like if you set x minus 2 equal to 0, put that in. Drop down the 1, multiply.
2 times 1 is 2. And then
2 times 1 is 2. Now I'm going to add. Negative 4 plus 2 is
Negative 2.
negative 2.
negative 2.
Multiply again.
Negative 4.
2 times negative 2 is negative 4.
Negative
Negative
7.
1. That.
Negative.
7.
I'm going with negative 7.
Negative seven.
Sorry, guys.
Now,
It's a lot easier.
what is negative 7? That's your remainder, yes? Okay. It's a remainder. Doesn't really mean anything to speak of. What does that 1 and that minus 2 represent?
So,
X minus 2.
y equals mx plus b.
Yeah. Remember, if this was x squared, right, then that means this is x.
X.
So this is the idea of y equals 1x minus 2.
That's what I was thinking. I thought it was slow. And I assume that's what it did. That's how you figured out like slant. But then I just could not put that together.
Yeah. So this line is the line y equals x minus 2.
I was actually thinking about this last night when I was in bed. I was thinking about synthetic division.
Why?
Ain't no way.
I don't think I've thought about it since
Why would
last
you do
year.
that to yourself?
I obviously hadn't thought about it because I'm staring at it and I know how to do it. Like I wasn't hesitating like how do I do this math problem? I'm just like, what's this called?
I'm
I'm glad you can remember the word because I was going to be here a while coming up with the word.
I still do have a question about this problem. So I know the answer is infinity,
Yes?
but it'll always be like infinity minus 4. Does that make any difference? Because I know it'll still go on forever, but
The
it'll
concept,
always
because it's infinity, and that goes back to the idea of infinity is not a number, it's a concept.
okay.
It's a, I don't know a better word than that, but you know, it's a concept of going on infinitely. Doing a small thing like minus 4 doesn't, I mean, you're still going on infinitely, so. Okay. Okay, summarize and discuss the characteristics and in behavior at horizontal asymptotes and slant asymptotes based on your observations in example 6. Okay, functions with horizontal asymptotes. Your limit as x approaches infinity when there's a horizontal asymptote is going to be equal to what?
Horizontal.
0. Wait.
It's your
I don't know why I'm saying it because I don't really know. I'm just taking a guess.
Okay, so, okay, it said example 6, right?
Yes.
Which This is example 6, yes?
No.
Horizontal asymptote. Here was a horizontal asymptote, yes? What did it equal here?
Coefficient.
2, which was my horizontal asymptote. We look at B, what did it equal?
0.
0, which was my
Horizontal.
horizontal asymptote. So what's it going to be equal to? Your horizontal asymptote. Now, I have it in my notes as B.
Oh.
But where B is a member of the reals, I'm getting fancy here.
What is 9?
Whoa.
What?
Okay, is that B like that for a certain way?
Okay, so B is just a B.
Okay.
That's just me writing a
Just
B
making sure.
because I always make sure my B's do not look like 6s. Okay?
All right.
Now, that little E was in this class we talked about that says is a member. That fancy R says reals.
So like a paragraph and an R together.
Sure. I don't know. It's some kind of fancy R. And that is y equals B is a horizontal asymptote of the graph. Okay. We do that because y equals B is what they usually use to represent a horizontal line. So y equals B is a, I'm going to say, horizontal asymptote of y equals f of x. Okay, so when we say that those limit equals B, it's because B is the horizontal asymptote.
I don't draw these things very well.
Functions with slant asymptotes. As x approaches infinity or negative infinity. What's that answer going to be?
Infinity or negative.
Depending on which slant we have, right? A positive or negative slant. I'm going to write it as plus or minus infinity because it's not going to be both. It's going to be one or the other, right? We just don't know what's going to be. And we just used synthetic division on the one we did, right?
Yeah.
To find the equation for the slant asymptote. You could also have to use long division. And then I also have test values to find in behavior, okay? But really using long or synthetic
Is there ever,
division to find the slant asymptote.
is there ever going to be a time that they make us use long division instead of synthetic?
I don't remember.
I hope not.
It's not out of the realm of possibility, I will say that.
If we do,
Without
we
a
go
good
over it. 'Cause I forget.
No, I expect you to remember it. Okay, anyways.
You don't know it.
Notice our sarcastic look on my face when I said that for anyone freaking out
Yes,
internally
sir.
right now, okay? In case anyone
I
missed that.
wasn't freaking out.
Okay,
Was.
in calculus. Okay, you must use new language in order to justify. So just, again, that's the whole using the limit notation to justify. That's, one of the big things we've been working with. So limit definition, justification of a horizontal asymptote. And what I can say here, basically, if this is true, right, if the limit as x approaches infinity equals b, or as x approaches negative infinity, then that's saying that y equals b is a horizontal asymptote. Okay, so I'm going to say if the limit as x approaches infinity of f of x equals b, or the limit as x approaches negative infinity of f of x equals b, so those are your two options here, then y equals b is a horizontal asymptote of the of y equals f of x is what I'm going to write. Okay, so that's more kind of summing up what we talked about over there with horizontal asymptotes. Okay. Example 8. I would love to fully go through example 8, but we're out of time, aren't we? Now notice example 8 does say challenge, yes. And it's trying to get you to, think through this a little bit. Because here, when we start thinking about that, what's the largest power in the denominator?
X.
Because it's square root.
Oh, yeah.
Okay. there's an x squared under a square root. Generally speaking, the square root of x squared is x. Now, although I think we usually divide by the absolute value of x, because here's the deal. If that x is coming out of a square root,
We don't know.
That's
It's
plus
Yeah.
or minus.
negative.
well, and that's the thing. Technically, it could have maybe been negative because we had to square it, right? And so that's what we think of absolute value there. I don't know. We don't really have time. You can't answer these limits because I don't have time to go any farther, but here's your graph. What's the limit as x approaches negative infinity?
-3.
Positive infinity?
3.
We can at least do that. What I just don't have time is to think about, to actually go through. But it would be, when you would go through, it would be dividing by the absolute value of x. Which you really have to think through the positives and negatives.
That makes sense.
So, I mean,
Because the limits are
Yeah.
positive and negative.
it's the
Symbol like that.
square root of x squared.
I know, right?
Okay.
What?
It's
So-
calculator, Mario.
I don't remember if there's anything in the homework that pertains to that. If so, obviously I will talk about it tomorrow. I just posted the key at the beginning of our class period, so it should be out there and available.
On
So finish the homework. We'll start 1.8 tomorrow
and then test next week.
and test next week.
Oh, I'm sorry.